Welcome to Miss Santa's math videos again. Okay, so we got factor pairs and prime factorization, okay? Factor pairs is when we take a number, we take two numbers and they multiply. Two numbers and they multiply. Okay, so let's do the number, let's say 36. We're gonna list all the factor pairs that multiply and equal 36. So most people would say 6 times 6 is one pair. Right away, perfect, okay? Now, here's a trick. We're gonna do something where we go double and half lane. We're gonna go half of 6 and double of 6, okay? Half the first one, double the second one. So half of 6 is 3. And then double of 6 is 12. So now we have 3 times 12. Now I wonder if we could do it as we divide by 3 and multiply by 3. Let's try that. So if we divide this into 3 and multiply by 3, now we have 1 times 36. Okay, now since this is an even number, we also could do something where it says 2 times, let me scoot this up, half of 36, so 2 times 18 is another one. So it looks like we still could do that double and halving. So we could double the 2 and half the 18 and get another factor pair. So we got double the 2, which is 4, and then we got half of 18, which is 9. So I think we have all the factor pairs. 6 times 6, 3 times 12, 1 times 36, 2 times 18, and 4 times 9. Let me double check if there's more. I think we're good. Okay, so prime factorization. Okay, this is a product of prime numbers. Okay, so I'll write it out. A product of prime numbers. So as a reminder, prime numbers are when a number has a factor pair of 1 and itself. So for instance, this 36 has so many factor pairs, it is not a prime. It is considered a composite number. Okay, 7 is prime. So an example for prime, okay, just to make sure, is 7. 7 only has 1 times 7 for its factor pair. So therefore, it is prime. So that is an example of a prime number. Just a reminder. Okay, so next part, we're going to do the same number. We're going to do 36. We have 36 right here. We're going to use a factor tree, so basically a Christmas tree, to help us get all the prime numbers that multiply to each other to get 36. Okay, so we could use any of the 5 right here, except for this one. Never mind, not any of the 5, except for that one. Any of these 4 options to start breaking down 36. So since 6 times 6 is the first one we use, we could start with 6 times 6. I'll show you another way to show it, okay? So let's say we got 6 times 6. We're gonna draw the top of our tree and do 6 and 6. Okay, so now 36 is broken down to 6 times 6. Now keep in mind, we are only going to circle the prime numbers. Okay, now, is 6 prime? Well, we know we could do 1 times 6, and then we could also do 2 times 3. Therefore, it's not prime, it's composite. So we could break this one down more. Extend the branches. So we got 2 times 3, and since this is also 6, we could do 2 times 3. And then we circle all the prime numbers. Okay, now if you took a different pathway for your factor tree, so let me show that example. Let's say we chose 2 times 18. 2 is prime, so I'll circle that. Now for 18, we could have 2 times 9, 3 times 6, and 1 times 8. Well, not 1 times 18. So we'll do 3 times 6. 3 is prime, 6 is not. So we could break down the 6, 2, and 3. Notice that the bottom of the branches are all the same numbers. You have 2 2s and 3 3s. Therefore, you will get the same answer no matter what pathway you take. So this is all multiple pathways, okay? So 36, the prime factorization of 36 is 2 times 2 times 3 times 3. If you want to use exponents, there are 2 2's, so 2 to the second power times 2 3's, 3 to the second power. Both are examples of prime factorization. And there you have it.